Okay, so kind of like yesterday's warm-up, this is actually kind of a forecast of where we're going. So the area formula for a circle is pi r squared. Very simple formula. And we're going to take this 9 inches, which is the radius, and put it right here. So that is going to be pi times 9 squared, which is 81 pi. And as we talked about yesterday, you can leave an answer in that term. So that's going to be 81 pi square inches. Or you can calculate it out and multiply 81 times 3.14 and get 254.34 inches squared. Either answer is acceptable. Now, working backwards, the diameter of a circle with an area of 42. Well, first we're going to write the formula again. Area equals pi r squared. Now, we know this is 42. Okay? And what we're going to do is we're going to take the area, 42, and we're trying to get to r to get to d, so we're going to divide by pi. And so we're going to do 42 divided by 3.14, and we're going to get a decimal, 13.38 equals r squared. Well, we need to find r, so we need to square root both sides. So we're going to take the square root of 13.38, which is 3.66. So r, the radius, is 3.66, and then to get the diameter, we're just going to double that. And so the diameter of this circle is approximately 7.32 meters. All right, a little bit of review. Find the values of x and y without using a calculator. Okay, so this is a 30, 60, 90 triangle. Okay, good concept to remember. 30, 60, 90, remember our magic number is radical 3. Okay, so we always want to go to the short side. The short side is opposite the smallest angle, the 30. So to go there, we're going to do y equals, remember we're going from the longest side to the short side, all right? And that is actually half, okay? So half of 8 is 4. And then x, we're going from here to the longer side, we're going to multiply by that radical 3, is 4 radical 3. Okay, this is a 45, 45, 90. So therefore, x is the same. These are both equal, so x is 7. And remember the magic number here is radical 2, so y equals 7 times radical 2. And we're timesing because we're going to the bigger side. Again, we have a 30, 60, 90. Okay? So to go from the long side to the small side, short side, we're going to divide. And remember, our magic number is radical 3. So I'm just going to write it right here. I'm going to divide by radical 3, which cancels, giving me y equals 11. And then I just double to get to the hypotenuse. X is 22. Good refresher. Okay, so as I said, our warm-up was foreshadowing. And here we are. The area of a circle formula, pi r squared. So, area of a circle with a radius of 2.5. All right? So, again, we write our formula. Area equals pi r squared. So, 3.14 times, well, you can't write both ways, remember. Sorry. So, that's going to be pi times 2.5 squared. And 2.5 squared is 6.25. So 6.25 pi centimeters is an appropriate answer. Or you take 6.25 times 3.14 and get 19.625, and that's square centimeters because we're talking about area. Now working backwards, find the diameter of a circle. So this time we do know the area, 113.1, equals pi r squared. So we're going to divide by pi, cancel. So 113.1 divided by 3.14 is 36.01 or 2. Let's just call it 36. I'm guessing, let me check. 113.1 divided by the actual pi symbol, yeah, that's going to be 36.001. So let's just say 36 equals r squared. Obviously, the square root of that is 6, but we're trying to find the diameter. So the diameter is 12, and that's centimeters. Okay. Now, we talked about finding the measure of an arc yesterday. Now we're trying to find the area of a sector. So if yesterday was the pie crust, the edge, we're talking about the piece of the pie here. And again, it's a very simple formula here. Okay? So the area of a sector is the measure of the arc divided by 360 times pi r squared. Let's think about that, what that means here. Pi r squared is the area of the entire circle. This is the portion of the circle. The measure of AB divided by 360, which is going to give us the area of just that portion. Okay? Now I just want to let you know we did skip number 2, so don't worry about that if you're looking in the book. Example 3. Find the area of the sector formed by UTV. So we're going to take the angle over 360. Okay? That's going to give us that portion. And then times pi and the radius squared. And now you're literally just going to type that in your calculator. 70 divided by 360 times 3.14 times 64. And that is going to give you 39.1 inches squared. All right? Now, it says find the areas of the sectors. So, this is the small section. And then, basically, we're going to find the area of the big section. So, that's going to be, instead of using 70, we're going to do 360 minus 70, which means this angle right here is 290. So we're going to do 290 over 360 times pi 8 squared. And again, you're just going to type that in your calculator as you see it, and you're going to get 161.97 square inches. All right, find the area of the circle. Okay, well, that means we need to find the small area and the big area and add them together. Now, this is an interesting problem because your initial reaction might be, well, I know 35 is the area of this section right here. So if this is 40, 360 minus 40 is 320. So that's the degree measure there. So if we just do 320 divided by 360 times pi r squared, problem is we don't have r. We don't have the radius. So let's think about the formula. We know that the area of the sector is equal to the arc measure divided by 360 times pi r squared. Okay? This is the area of the circle. That's what we're actually trying to find out. So let's think about that as just a whole thing. Pi r squared as one thing. We know that the area of the sector is, right there, 35. We know the measure of the arc is 40 divided by 360 times, I was going to put a big A there for area. Okay? Well, 40 divided by 360. Okay, you can just reduce that. Is 0.1 repeating. Okay, 40 divided by 360. That looks like a T, doesn't it? Okay. Times A. Well, I'm just going to divide by 0.1 repeating. And get the area of the circle is 315 square meters. So it's kind of a complicated one, working backwards and kind of abstract. Okay, last example. Rectangular wall has an entrance cut into it. You want to paint the wall. To the nearest square foot, what's the area of the region? Well, basically what we have here is we have a rectangle and we have a half circle on top of it. Okay? So we need to find the area of both. Okay? So first off, we need to find the area of the rectangle. Okay, my bad, I misread that. We need to find the area of the door, which is the rectangle and the half circle, and then subtract it from this blue area here. So first we're going to find the area of the entire area. And that's going to be the length times the width. Now the length is obviously 36. The width is 16 plus 10, so 26 feet. So the area of the rectangle is 36 times 26. So that's going to be 936 square feet. That's the entire area. But now we need to find the area of the rectangle, door, and the half circle. All right? Now you can see the rectangular part of the door is actually square. It's 16 by 16. All right? So the area of the door is 16 times 16. So I'm going to kind of circle the numbers I need. So 16 squared is 256. Okay? That's the area of the door, square part. Now we need to find the area of the half circle. Well, that's going to be pi r squared. Well, what's the radius? 8. Well, we want a half circle, so we're going to divide by 2. So 3.14 times 64 divided by 2. And that's 100.48. So now what I'm going to do is add those three numbers together. 100.48, add the two numbers together, sorry, plus 256. And that gives me 356.48. That's the entirety of the door. Now if we subtract that from 936, we'll get the area we need to paint. So 936 minus 356.48, and our final answer is 579.52. Does not look like a 7. And that was square feet. Final answer.